Ignition sequence starts.
Good morning, and welcome to this look at the activity in the International Space Station Flight Control Room at the Johnson Space Center in Houston. These men and women are monitoring the health of the station's systems and helping the Expedition 67 crew members, as needed, as they finish up the last tasks on their agenda for the work week. Commander Oleg Artemyev and his American, Russian, and Italian crewmates are busy wrapping up a week of science activity, but they've also been getting ready for the undocking of a cargo ship and the next Russian spacewalk, both of which are on the schedule for next week.
Welcome to Space to Ground. I'm Chelsea Bayarte. Can you believe it's been 5 years since the Advanced Plant Habitat launched to the International Space Station? Since 2017, the habitat has grown wheat, radishes, chili peppers, and we're just getting started. This week on the space station, the astronauts are prepping the habitat for its next experiment. This upcoming experiment looks at whether gene adaptations in one generation of plants grown in space can transfer to the next generation. Studying plant adaptability not only helps researchers better prepare astronauts for growing food during long-duration missions on the moon, but it can also provide lessons and technologies that could improve farming methods here on Earth. While astronauts are studying ways to grow their own food, most of their meals are delivered using a cargo spacecraft. One freighter has nearly completed its delivery and is set to come back home next week. SpaceX's 25th Commercial Resupply Services mission arrived at the space station back in July and delivered nearly 6,000 pounds of science and supplies to the crew in orbit. Now nearing the end of its mission, the crew has been tasked this week with packing the Cargo Dragon for its return trip back to Earth. Cargo Dragon will return samples from experiments conducted on the orbiting laboratory for analysis by researchers on the ground. Be sure to keep up with the Space Station blog and follow @space_station for when to watch the undocking live on NASA TV. Also coming up next week, 2 Russian cosmonauts are suiting up and heading outside of the space station for a spacewalk. Oleg Artemyev and Denis Matviev will spend nearly 7 hours working on the European robotic arm to install cameras, remove equipment used during the arm's launch, and more. This will be the 7th spacewalk for Artemyev and the 3rd for Matviev. Artemyev completed a spacewalk with European Space Agency astronaut Samantha Cristoforetti just last month. While out on spacewalks, the crew members are busy with their tasks, but sometimes take a moment to look down at the beauty of the Earth below them. Fortunately, we don't have to wait until the next spacewalk to catch a glimpse of what they're seeing through their eyes. NASA just released views of the Earth captured from the International Space Station, available in 4K resolution. In nearly 1 hour of clips shot in 2021, you'll find spacecraft arriving and departing, auroras, city lights at night, and much more. Just hit play, sit back, and enjoy. That's Space to Ground. Thanks so much for watching. See you next week.
The SpaceX CRS-25 cargo ship, due to undock from the station and return to Earth next week, delivered lots of supplies for the crew members as well as new science experiments. One of them, developed through NASA's Genes in Space education program, came from a student investigating pathogens in water in space.
Mini-PCR Bio, we are a startup that makes equipment for biology research that is smaller and more affordable than lab equipment usually is. Genes in Space expand access to science in 2 different ways. We invite students to propose biology experiments to be implemented on the International Space Station using Mini-PCR Bio equipment. By doing that, we're able to empower students to act as real scientists.
I'm sending BioBits technology to the International Space Station. BioBits is this new and emerging tool that allows us to synthesize proteins at the point of care just by providing a simple DNA sequence. It's already highly optimized for the space environment. It's low cost, it's low resource, it's portable, and you can easily harness it to develop user-friendly detection systems or diagnostic devices.
I love that we're able to do this as an outreach and an educational tool. When you get to tell them that they could design an experiment and they could actually fly it on the space station, it's such a cool thing for this generation, and it gets kids really, really interested in STEM.
Our students aren't just repeating experiments that have been done on Earth and space. They're really creating new technology, new workflows, and things that just can't be done on Earth.
BioBits has very far-reaching implications. In addition to supporting astronauts, we can also implement it in remote or low-resource environments on Earth, such as, in submarines or on mountains when you go hiking.
These are really cutting-edge techniques. The results that we get from these experiments get published in peer-reviewed, internationally recognized journals. The students are truly contributing to our understanding of human health and genomics and physiology in space.
Working through the Genes in Space program is really our marquee program for STEM education at Boeing. And that's the foundation for our next generation of employees. They're going to be our next engineers, our next scientists.
Mini PCR has been so helpful, and it's been a very transformative experience. It's also shaped my interests in science and really captivated me in the field.
We're really excited to be able to have this opportunity to see our tools being put to use on the International Space Station, and all the doors that we believe in opening here on Earth, we're opening them in space as well.
The International Space Station orbits 250 miles above the Earth and the vast diversity of plant and animal life that exists here. Bringing some of those species into the weightless environment has allowed scientists to study them in ways they can't in 1G, and that's led to discoveries about how humans can better survive in space as well as on the home planet.
The International Space Station orbits Earth in the cold, solitary vastness of space. But look closer. There's a cornucopia of species bringing the interior of the station to life, and with it a plethora of scientific knowledge contributing to humans learning not only how to survive in space, but thrive both on Earth and beyond the edge of our planet. Animals that fly in the air, animals that swim, squirt, and float in water, animals that creep, crawl, walk, and run on land, all are being studied to learn how they react and adapt to microgravity conditions. Since many share similar cells, tissues, and other organic structures to humans, each is studied for what they can reveal to help astronauts withstand the rigors of long-range space travel. Some examples. The tardigrade, or water bear, is well known to possess genes that can withstand extreme hot and cold temperatures, dehydration, and radiation. What can we learn from these amazing creatures that might help keep astronauts safer in extreme environments? Astronauts exercise 2 hours a day and closely monitor their diet. However, the loss of muscle mass that occurs in space is still a serious obstacle that researchers are working to overcome. As such, roundworms were exposed to a microscopic obstacle course to study their unusual muscle strength, while zebrafish have helped researchers develop countermeasures for muscle weakness. Another fish, the Japanese medaka, have helped improve our understanding of the mechanisms behind organ tissue changes. And of course, one of the most common space travelers, the rodent, was found to be more physically active in space than their Earthbound counterparts in one experiment. Why? This matters to scientists who are studying the effect of microgravity on bone loss. Jennifer Buckley is the Deputy Chief Scientist for the International Space Station Program Research Office at NASA's Johnson Space Center. She explains how studying multi-generational organisms can have big impacts on our understanding of both animal and plant biology in space. Fruit flies multiply so quickly, we can observe several generations at one time. We can trace the actual development of an organism from conception to birth to adulthood and old age, and the genetic changes from one generation to another are easy to track. Regarding plants, Buckley says, plants develop differently in microgravity. They don't know which way is down anymore. They no longer have a gravity signal for their root structure. So we examined their RNA to see how it's giving directions and signals, and how that differs from the way plants behave on Earth. Many types of plants are grown on the station, from flowering plants to leafy greens to vegetables. What we learn could influence our approach to growing different plant types in the future. Practical benefits for those on Earth have come from studying all these various forms of life in space. Traditional fertilizer can't be used on plants in space, as they're not grown with traditional soil. As a result, NASA scientists, working closely with the private sector, developed a fertilizer that would release its nutrients over a specific amount of time. The process proved to be not only successful in space, it can also be used on Earth in vertical farms and urban plant factories. Life in space is not new. The study of numerous species going back several decades have given researchers multiple views of how life can exist and thrive in the harsh environment of space. Buckley concludes, we'll conduct hundreds of experiments during each 6-month expedition. We want to study a broad diversity of organisms that will help us travel beyond low Earth orbit, while also giving us insights that may improve life on Earth. For more information about the multitude of life on board the space station, go to www.nasa.gov/ISS-science. To discover more about the space on, around, and beyond our planet, visit science.nasa.gov.
The first decade of the International Space Station was the decade of construction. The second decade moved from initial studies to fully utilizing the capabilities of this orbiting laboratory. We're now in the decade of results. With more than 20 years worth of experiments having been conducted on the station, more breakthroughs are materializing than ever before. Take a look. One big focus of science research on the International Space Station is to learn about the effects of long-duration spaceflight on the human body, as NASA makes plans to return to the Moon under the Artemis program and prepare for human exploration of Mars. During the recent extended mission of astronaut Mark Vande Hei, he spent many hours on lots of other experiments too, supporting everything from plant research to physical sciences studies.
Good morning, Expedition 64.
Good morning, Expedition 65.
Good morning, Expedition 66. We are happy to be working with you today.
Good morning.
Anytime you can take science experiments and change the variables, you learn something new. And the space station provides unique ability to have solutions where you don't have sedimentation, where you can keep a homogeneous mixture, for example. Buoyant forces just don't work the same way, so the way combustion works is different. But also I'd say space is exciting because we human beings are explorers at our core, and we want to understand better how we fit into the vast scheme of things. And the further we go, the more we learn.
What was your favorite experiment on the International Space Station?
Toby, great question. My favorite experiment was the one that I got to eat. It was us growing hatch chili peppers in our plant habitat. And some of them got frozen to go back to the ground, but many got to stay with us and we ate them.
Station Huntsville on 2, we have video in Node 1. Look at those chili peppers.
What we're doing, in effect, is practicing keeping people healthy on a long trip through space. The big difference is when we get our first folks to Mars, we're not going to have a staff of nurses and doctors there to make sure we're healthy and take care of us. So being able to contribute to that is something I will always be very, very proud of.
On behalf of the entire control team, we just wanted to say congratulations to you and Piotr on 300 days in space, and we're just so proud of you and all the work you're doing.
That was very kind of you to say. This is definitely a team accomplishment. Thanks again for the words.
It's a beautiful view when you turn off all the lights inside the space station and you can look out the window, and it is glorious. And this very thin atmosphere, which is essential to our existence, that's a very finite resource that we need to protect. I will miss the certainty that every day I'm spending contributing with innovations in science, technological demonstrations that are helping out all of humanity and pushing the boundaries of human existence. There is a very strong sense of purpose for all of us up here as we do this work.
All of the equipment and systems that make up the International Space Station and the hardware the astronauts and cosmonauts use to execute science experiments there were developed by engineers using a design process that helps find solutions to technical problems. In this demonstrations episode, NASA's Tom Marshburn and European Space Agency astronaut Matthias Maurer explain the process and talk about how station technology continues to evolve to meet the needs of the mission.
Hello, my name is Tom Marshburn.
And I'm Matthias Maurer.
And we're astronauts living and working aboard the International Space Station, orbiting 250 miles above the Earth's surface.
In the not-so-distant future, we'll be sending astronauts on missions that go deeper in space than we ever have before. To do that, we'll need to design transportation systems and habitats able to meet our needs. Engineers are designing, building, and testing these systems right now.
You may be wondering, how do they achieve this, and what steps do they take? The engineers use what's called the engineering design process. This process involves a series of steps to guide them in developing a solution. Each piece of technology on the space station and in your home or classroom involves engineering. But what exactly do engineers do? Well, they use science, math, and their own ingenuity to create solutions to technical problems. Examples of technical problems could be developing more efficient light bulbs or vehicles, lighter sneakers or aircraft, an orbiting space station, and transporting humans to Mars.
Yeah, Mars is great.
Here's one example of what the process looks like.
Step 1, identify the problem. Step 2, identify resources and constraints. Step 3, research. Step 4, develop solutions. Step 5, select the best solution. Step 6, build the solution. Step 7, test and evaluate the solution. Step 8, record and present the results. And step 9, improve the solution.
Take a look at the space that we are currently living and working in. This space is filled with things that have been engineered using the engineering design process. Some of these items are low-tech, like packaging, storage compartments, and fasteners. And some of these items are high-tech, like computers, cameras, and science experiments.
A great example of an engineering solution to something you might be surprised is a problem in microgravity. How do we drink fluids? How do we keep them contained? And how do we get them in our mouth without making a mess everywhere? Here's our standard drinking pouch. I've got some grape drink in here and a very nicely designed straw. It's just perfect for living in space. If we didn't have this straw, start to see some fluid coming out there. I don't want to make too big of a mess, so I'm only going to demonstrate what would happen for a second if we didn't have our straw here. And this would come right off. And it's getting on me right now, so let me drink this up. But as you can see, we have a clasp here, very nicely designed. It pinches the straw at this point here, and that keeps more fluid from coming up the straw. And that way, if you want to drink something, you just open it up when you need to drink. You have to remember to close it again before you pull it out of your mouth. Otherwise, you're going to get more fluid coming out.
Hey, Tom, you're floating. I think that's not convenient for working, no?
That's true. Got a little bit of a problem in that if I do any work with my hands, I'm going to be pushed away from where I'm working. And if I have to find a place to put my feet, which I really want to do in order to get any work done, sometimes I can't find a place to put my feet. Still working on it. So I got a problem.
Based on astronauts' feedback and data, we developed these rounded hand and foot rails so that you can stay in one place comfortably for short periods of time. To maximize comfort, we also have these socks that are padded with rubber on top and bottom. For longer periods of time in one workspace, we engineered these foot restraints with cloth straps. You can slip right in and adjust them.
Thanks for exploring the engineering design process with us.
I'm going to send it back to Earth so you can solve your own engineering problems using this process.
See you again soon.
The astronauts who spend 6 or more months in low Earth orbit on the International Space Station need a little time to get used to the microgravity environment. And when they come home, they spend time adjusting back to life in 1G. In this new episode of Down to Earth, recorded in October of 2020, now former astronaut Chris Cassidy talks with astronaut Woody Hoberg about adapting to life where things float and where they don't.
Chris, welcome back.
Oh man, great to see you, man.
I can't believe it was less than a week ago you were in space.
I can't either, you know, it all happens so fast. It's so cool. And next thing you know, you're seeing your friends and a week ago you were in space.
Take me through a little bit of the rehab so far. Like, how do you feel right now, less than a week out?
I feel really good. I think that our bodies are like amazing because getting there to space, I had almost zero adaptation opening the hatch and floating in. My body just knew how to do it. And I feel like it was better coming back this time than last time as well. I mean, really little dizziness or anything like that. And so rehab has been, at the gym, and we're focusing on balance and changing direction and that sort of thing, but it hasn't been vomit-inducing or anything like that. It's been not so bad.
I saw the photos of you smiling right after landing. It looks like you were just right at home.
You know, I was smiling because I finally got to stretch my knees out. I'm like, oh, thank God, my knees.
You know, you talked about adapting. We obviously see videos of you down here in Mission Control, and you just look like you're completely comfortable. You're really good at moving in zero-G, in weightlessness. Does it take 3 missions to get that way?
It doesn't take 3 missions, but it takes a good chunk of a couple weeks or a month, maybe longer. Everybody's different. But for instance, what I really enjoyed was we got to space. Anatoly had been there multiple times. I'd been there a couple times, but Ivan hadn't. And watching him gangle his way through the hatch and the first couple days kind of move around with extreme uncertainty and even inside looking for the next place to put his hand, and then slowly watching his comfort level, and man, towards halfway through and the rest of the mission, he was just zipping around just like he'd been there a million years. So again, your bodies and your brains just sort of adapt to it. And the other thing is you get used to not needing your hands to do stuff, and your feet just start instinctively grabbing handrails, but your feet just find it. And in fact, there was a few times where I needed to move a handrail for some science reason, or payload had to go there, and my foot would naturally swoop in that location and there would be no handrail there. And I realized, well, that's pretty crazy. Without even thinking, my foot knew that that's where the handrail should be to grab, but it wasn't there.
Being your 3rd mission, did it come back, you know, a minute in, an hour in?
Minutes, yeah, like really fast. And when I was a shuttle guy, I came to the space station, but my analogy is like a vacation rental. Like, you're enjoying the house, you're enjoying the facilities, but you don't care how the VCR and cable wiring is. You don't care how the sprinkler system works. You don't care the nuance on the thermostat. Everything should work. And if it doesn't, you call the landlord and say, fix this thing. That's like a shuttle visiting person for just 2 weeks. But my last mission, and again this one, now it's not a vacation rental, it's your house. And you care about how the wiring on the TV system is. You care about the sprinkler system not going on time, and you care about trash day and all those things, and it's your home. And you have like this real ownership of it. And I remember thinking how cool that was last time when I got to that point. And this time it was right away, because I only overlapped with Drew and Jessica for a week, maybe 9 days. And then I was on my own, but it was no big deal because I'd already had that feeling of ownership. And the space station had changed, but it really hadn't changed a ton, so I felt really quite at home. Yeah, it was a neat feeling.
If you want another look at any of the stories we showed you today, go over to YouTube and Facebook at those addresses right there, and you'll find them all, along with lots of other great features on a wide variety of NASA topics. And to make things even easier for you, you can get the latest from all over NASA delivered to you every week if you go to nasa.gov/subscribe to sign up for the NASA newsletter.